Let's finish this up by taking a step outside this incredible house of technology that we've created, and let's marvel at the brilliance and the competency of nature. Because outside exists the culmination of almost 4 billion years of research and development. And when we start to quiet our human cleverness, we begin to realize that nature has created functional, sustainable, and beautiful solutions to some of the very same problems that we're grappling with today. For example, we're not the first. We're not the first to do packaging. We're not the first to do adhesion. We're not the first to use color. Nor are we the first to make structures. So let's envision 2020 with a new perspective. Let's use biomimicry as our perspective. And what that means is it's about going out to the natural world and learning from her, and then consciously emulating the forms and the processes and the systems in nature to make more sustainable designs. So imagine a solar cell that was inspired by a leaf. Or imagine an electric eel helping build better batteries. Imagine we went to the mangrove to help us make better desalinization technologies. When we look to nature as a model, our perspective completely changes. And we start to see it not as something to take from, but something that could teach us. And when we do that and apply it to our technologies, the results are stunning. For example, by emulating the bumps on the front edge of a fin of a humpback whale, Dr. Frank Fish, which is his real name, he made a wind turbine blade. And this wind turbine blade is 20% more efficient, it runs at slower wind speeds, and it runs quieter than a traditional or conventional wind turbine blade, just by using that tubercle technologies, copying the tubercles of the humpback whale. By mimicking the hydrodynamic shape of the aptly called boxfish, Mercedes-Benz has made an incredibly efficient car. And not stopping there, they also designed the cleverness of bones and how bones add materials where the stresses are higher and remove material where the stresses are lower. So what they've done is they've made a car that is 40% lighter without compromising its safety. And it's also reduced the pollution of a diesel car by 80%. And in our efficiency terms, it runs at 2.8 liters per 100 kilometers. Translated, pretty good. An architect by the name of Mick Pierce, he went to the termite mound in Harare, Zimbabwe to help him build a shopping center. And what's cool about a termite mound is that outside, the temperature can fluctuate from 2 degrees at night to 40 degrees in the heat of the day, and that's in a 24-hour period. Inside the actual mound, it maintains a constant temperature of 30 degrees at all times. And it's done based by its circulation system and all the tunnels and the networks of tunnels in the termite mound. So copying that, emulating that, he put it into his, he built a building using that same technology. This building uses 1/10 of the energy required to run a building of that size in that environment. And in the first 5 years, it saved $3.5 million on air conditioning costs. It's amazing that we can look to nature and see that there are really efficient designs. And it's a kind of a duh moment. Yes, it's been around for a long time. But this whole bio-inspired design, it's not a new idea. And I don't want to trick you in saying that it is. I mean, if you think through our history, there are spatterings of examples of our ancestors looking to nature and creating incredible technologies. Think of indigenous people of the north who emulated polar bear dens to make igloos. Or they copied the shape of an Arctic harefoot to make snowshoes. I mean, people like Leonardo da Vinci, or if you've ever been to Barcelona and seen Antonio Gaudi's church, there are constant examples of emulating nature and consciously emulating nature. But what's different about biomimicry is that it's ushering in a new evolution and a new era of bio-inspired designs. And it's doing that by deepening the conversation. And not only do we want to emulate nature's forms, but the way that nature builds. And that's how we begin to fit in with the natural world. So for example, yeah, that's really cool, we made a car that's a lot more efficient. But that doesn't get us off of our dependence on oil or our dependence on heat, beat, and treat manufacturing processes. So the next step in biomimicry is looking to nature not only as a model, but as a measure. And I know this is incredibly difficult to try and match the way that nature builds, but we really have no excuse because the natural world exists in the exact same context that we do. It's dependent on the very same resources as we are, and it's limited by the very same laws of physics and thermodynamics, so we really have no excuse. And to quote Janine Benyus, nature does everything it needs to do. It builds with a beguiling simple set of common raw materials that are procured locally, that are manufactured at body temperature and pressure, and all processed silently in water. So imagine our system could emulate that. Imagine we measured our system based on these principles in nature. Imagine we used benign manufacturing, water-based chemistry. Imagine everything was recyclable and ran only on sunlight. Imagine we built with locally in tune in mind, being locally in tune. If you want to find some of the coolest inventions on this planet, I suggest going to the most uninhabitable places on this planet, like the Namib Desert. This is the Namib beetle. Got it. And the really cool thing about this creature is that it lives on the desert, but it's able to sustain itself and get enough water, and it does it with an incredible technology. You see those bumps on the back of its wings? Those are hydrophilic bumps. And what it does is in the night, when the moisture content is high in the air or there's fog rushing through, it'll actually lift its wings up. And as it does that, the water collects and it's attracted to those bumps and it starts to actually ball up. And it's so cleverly designed that when the water is heavy enough, the ball rolls directly into its mouth. Come on, how cool is that? Imagine we built locally attuned. We use shape rather than material. Imagine we used information rather than energy to make our technologies. Janine Benyus coined the term biomimicry in 1997 in her book. Like I said, bio-inspired is not new, but biomimicry is. And since she wrote this book in 97, her and Dana Baumeister and the Biomimicry group, they've been igniting a community of unlikely collaborations. Ecologists and engineers, biologists, designers, artists, economists. They're all stepping out the back door of this great house of technology that we've created and started becoming nature's apprentice. Companies like General Mills, General Electric, Nike, Volvo, they're all joining the biomimicry dialogue. Schools like Harvard, Duke, Georgia Tech, OCAD in Toronto, they too are embracing this idea and perpetuating this discussion. To give you an example of how far this has grown, between 1985 and 2005, patents containing the word biomimetic increased by a factor of 93. To put that in perspective, all other patents without biomimetic in its title only increased by a factor of 2.7 in that exact same time period. This has come at an incredible time, and I think, in our species' history. I think we're at a point where we're becoming abruptly aware of our competencies and our incompetencies. And I think we're starting to figure out that we really haven't got it figured out. But with that in mind, Janine Benyus, when I met her in 2007, she said to me something I'll never forget. She said, in the grand scheme of things, our species has only really just arrived on this planet. And we shouldn't be thinking of ourselves as necessarily the bad species, but just a very young one. And when we think like that, and when we start to apply biomimicry with each new invention, with each new discovery in the natural world, we start to take the steps in the right direction. We start to find a balance between our system of technology, our great house of technology, and the technologies out in the rest of the world. So let's go outside. Let's start ushering in this new era that's based not on what we can take from the natural world, but what we can learn from her. And the best part about biomimicry is that it's a methodology that works with what we have now, not to start again, but to start to fit in. Thank you very much.